Hi, Math 1 students. This is just a little video support for this review worksheet that we have after you've taken the Unit 5 assessment. We're getting into Unit 6 and we're going to have to remember many of the skills that we've developed throughout the year, like solving equations, graphing lines, being able to write the equation of a line. So this is a streamlined video. We're just going to have a couple of problems covering the topics on the worksheet. By the way, these problems are not actual problems on the worksheet. They're just here to give you an example as to what you're really asked to do. So with no further ado, let's jump into solving. Solving means get x alone, and we generally have built a wall. If we see an opportunity to distribute, we will. Negative 2 times 3x is negative 6x. Negative 2 times negative 2 is a plus 4, and we're going to carry this minus 3x over. But very, very importantly, what we need to do is, before we think about really moving things about, getting rid of terms on one side, what we want to do is understand that we need to combine like terms. Negative 6x and a negative 3x are here on one side, and we're going to be able to deal with that. So very quickly, negative 3x minus 6x, or minus 6x minus 3x if you'd rather, that's going to be a negative 9x. You can add these numbers on a calculator if you need to. So now things are looking a lot better. We've got this negative 9x plus 4 equals 22. We can minus a 4 from both sides. 22 minus 4 is 18. One more little baby step here. Negative 9 is multiplied to x. So I'm going to divide by negative 9. Final answer, 18 divided by negative 9. You'll get negative 2. Take a look at problem 2. Very similar. Very, very similar problem. We're going to have to distribute. We can build a little wall here. We've got our 3x plus 5, but negative 2 times 4x is a negative 8x. Negative 2 times a 3 would be a negative 6. And much like we just did earlier, we should really look at a side of an equation and always ask ourselves, are there like terms that I can put together? And actually there definitely are. You can see really we've got like terms involving x. That's your 3x minus 8x. 3 minus 8 is negative 5. That's negative 5x. And here's a 5 and a minus 6. 5 minus 6 would be a negative 1. And very quickly we've moved on to having a much simpler equation. At this point, we can add a 1 to both sides. 9 plus 1 is a 10. And then we can divide by negative 5. X will equal negative 2. So if you needed a refresher with solving equations, hopefully this has helped. Let's review graphing lines. And you might remember that we had y equals b plus mx, or mx plus b. We had a starting point. We had that y-intercept. The starting point, also called the y-intercept, was 0 comma b, and our slope is m. So I'm going to look over here to number 3, and I'm going to say, well, hey, I've got that negative 2 starting us off. You can see that our starting point is going to be 0, negative 2. Our slope, the slope, of course, is what is multiplied to x, and that's going to be a 1/2. And slope is always giving you two directions. It's rise over run. So hopefully you can see where we're going with this. You've got your starting point. That's always going to be the number that's not multiplied to x. And we're going to start with that. That b can even mean to begin. 0, negative 2, well, it's right here. Slope, go up 1 step, go 2 steps to the right. Go up 1 step, go 2 steps to the right. Keep doing that. Likewise, we could reverse the order. We could go down one step and 2 steps to the left. Down one step and 2 steps to the left. We could do that one more time. At the end of the day, it should be very clear that you have a line when you connect those points. Let's come over here and very quickly do another problem. You can hopefully see rather quickly that likewise we have our information embedded in the equation. The number without an x is the 4, so that's our starting point. You can see even up in this left-hand corner, that's 0, 4. Our slope is going to be -2. I'm going to put that as -2 over 1. And that means we go down 2 steps, we're going to go 1 step to the right. So let's get started. Your starting point, it's going to be right here. That's 0, 4. I'm going to go down 2 steps, 1 step to the right. Down 2 steps, 1 step to the right. I'm going to keep doing this. And as you continue to do this, you should see a line forming. Of course, you could reverse. Going to your starting point, you could say, what if I went 2 steps up, 1 step to the left? Very quickly, you could see that you get this line formed. So that's an important skill. In fact, we're going to be graphing a lot in this upcoming unit. And we're actually going to be graphing some lines in this form. So it's really just review. Likewise, as we're looking here for number 5, we're going to work backwards. Can we write the equation? Well, I hope you can see very quickly that we've got our starting point. Our starting point is 0, 3. And then you can think about slope. Well, your slope, if you're thinking about it, you're going down some, you're going some to the right, and you can see rather quickly that you're going down 2 steps and you're going right 3. So you can get this slope really just from the graph. Slope is rise over run, and in this case our rise is indicating to go down. It's your change in y over change in x. I do want to say this much too. You could get that same idea from a table. Look, if I just went to 0, 3, this starting point, and then if I came over here to 3, 1, you could see that your change in y, you're going down 2. How about your change in x? Or your change in x, you're going up 3. And slope, like I said, is always change in y over change in x. You'd get -2/3. So whether you would utilize a table, whether you just look at the graph, hopefully now you could say, well, I know y was equal to b plus mx. Well, y is going to be 3. That was our starting y value. And my m is -2/3. So I'll have -2/3 x. Look at that. Likewise, if we come over here, our starting point, I think you can see hopefully rather quickly, is down here. Starting point's always your y-intercept, by the way. It's 0, -4. And then we can think about the slope. Hopefully you can see your slope here. How am I going from that starting point? Well, you can see right here I'm going up 1. I'm going right 2. Up 1, right 2. So, what we've got right here is your m. You're going up 1, right 2. It's going to look just like so. By the way, again, you could have gotten this information via a table. You could have had 0, -4. This point here would be 2, -3. You could see your change in y. You're actually going up 1, right? If you look at that. Your change in x is going up 2. Your m is change in y over change in x. But it's so helpful to just look at the graph, though. Right? It's so helpful to do that. So what do we have? We have y equals b plus mx. And this is our b right here. So I'm going to have y equals negative 4 plus 1/2 x. And actually right here we could have, in this answer space, I've magnified the screen so much for this other problem, we could have had that. All right, we've got one last skill set, and it really is involving finding a y value if you plug in a 0 for x. We're going to do this a lot, this skill set coming up, and even though we haven't done something like this exactly, in an earlier unit, you could see when x equals 0, you're going to say replace 0 in for x. Anything times 0 is 0, right? It just wipes out. So look at that. You'd have y equals 10. Let's do this last one. Plug in 0 for x. Show the algebra that will result as you solve. So let's do that. This is 5 times 0. And again, look what's happening. 5 times 0, guys, that's just a 0. That's 0 plus 3y. So final step, divide by 3. Look at that. You'll have y equals 5. So that's it for this little bit of support. So if you have been struggling, really hope that this will make this worksheet a lot easier. So good luck to everybody. We'll see you soon.